the Department of Optical Science and Engineering at the University of North Carolina at Charlotte. She earned her PhD from Purdue University in low temperature physics in 1995 and was a postdoctoral fellow at Michigan State University until 1997. Dr. Mohiuddin-Jacobs has more than 25 years of teaching experience in undergraduate physics courses and at high school. Furthermore, she is extensively involved in outreach activities such as Science Olympiad, AP Physics, and promoting girls in STEM education. Dr. Mohiuddin-Jacobs is one of the professors who I know who cares most about authentic learning and student success. She has implemented several strategies for classroom engagement and student active participation in her class. Today she is presenting on the topic engaging students in learning physics with video lecture quizzes. Dr. Mohiuddin-Jacobs, please proceed with your presentation when you are ready. Thank you so much.
Thank you so much, Umesh. I didn't even realize how important I sound. I didn't realize that I do so much. But anyway, I'm grateful. I mean, thank you so much for letting me speak today. I work quite closely with Umesh every now and then. And when I heard about this organization, actually, I requested that maybe I can join and I can share some of the things that I do. I teach introductory level physics, and the one that I am currently teaching, and that's where my focus is, it is physics for second semester algebra-based physics at our university. And it's a large class. I have, in a given semester, regular semester, I have about 200 students. So that's a lot of students whose issues and things that you have to think about. And then physics 2 is, we do electrostatics, currents, and magnetism and optics. So we have three.
Dr. Farida, are you sharing the slides or not yet?
Not yet.
Oh, okay.
I'm getting there.
Sorry. Yeah, please.
No problem. Let me go ahead and start sharing. I just didn't say any of those things in my slides, so I'm just giving you my introduction about my class.
Okay, thank you.
All right. So now you can see my blank screen, right?
Yep. Thanks.
So one of the thing about since all of you are somehow related to physics in one way or the other, you realize that the big difficulty is that learning physics involves multiple steps. But if you think about it, just about everything that you learn has multiple steps. But somehow physics learning multiple steps seems to be very difficult for students. And that's probably because of the preconceived notion that they have. So some of the things are that they need to know what underlying physics principle is anytime they are learning physics or solving a problem. They need to determine which concept is applicable in a given situation or the problem. And then they have to do the math. And then they have to, at the end, which most of them do not do, is do a sanity check to ensure that their answer is correct and it makes sense. I mean, a lot of the time when I give them problems, I see that they find speed of a little rod, something that's moving like in the order of 10 to the power 23 meters per second. So we are somewhat clueless about what we're solving. So these are the challenges that we face. Now, as I mentioned, Physics 1102 is the second semester of an algebra-based introductory physics course. Students taking the one that I'm teaching, they come from different math and physics backgrounds. Some of them are coming from our university who did the first semester here. Some come from community college. Some went out from school and then they come back because as a post-bac because they want to go to medical school, and this is one of the required course. So as a result, it makes a very big challenge for us. And as you are probably aware of, if you're teaching these classes, that students are extremely afraid to make mistakes. So they don't know how to choose, how to think. Often they would just randomly select some equations from an equation sheet, and without just much thinking about, is it really applicable over here? So what I notice when I like to interact a lot with my students, and when I get a chance when they talk to me. So a lot of the time what I find is that many of them, we can't reach everybody, it's a large class. Many students, they really do want to learn the material, but they have no idea how to go about it. So as a result, they put their emphasis in wrong place. So my presentation today is about one of the methods that I devised to engage the students to help them learn Physics 1102 concepts, which is electrostatics, magnetism, current circuits, and optics. All right. Now, since I'm dealing with introductory level class, these students have a lot of things on their plate. They're, first of all, they're freshly out of high school. If they're taking it, they don't put it off. And for them, just the whole process of learning is different because the topics in colleges are presented differently than the way they were presented in schools, in high school. And they are also taking too many classes in large class setting, and they usually don't feel that they belong to the class. They're just one of many faces. They just have a little bit of kind of disconnect with the class. And then on top of that, these days, which is the biggest challenge, is that they get very easily distracted because of all these social media, gadgets, cell phone, whatever they have that's available to them during a class. They get distracted very easily. Their attention span is very low, and they stop coming to classes if attendance is not taken. So these are all kind of challenges that we have to deal with in a positive way. And we can't take away, in a college setting especially, we cannot take away their cell phone anymore because they need it to access course material during the class. So we have to deal with it, basically. Now, when we grade their exams, what we noticed that some questions that we ask, they are very basic. You should know, if you're taking a physics class, you should know these things. And if you do come to class, or if you were paying attention to a little bit of what we were doing in the class, then you wouldn't be, your answer would not be that far off. I mean, sometimes they're just wildly crazy answers. So it was a little bit, you know, again, I mean, all of these are big challenge. So many students are unable to answer those simple questions, and they just select some kind of random answer. So what I felt is that it would be better outcome in students' answers if somehow I could just engage them in paying attention to the course material that are in my PowerPoint lecture slides, or attend the live lectures. We just need to get them, they signed up for the class, we just need to somehow get them to look at it. And that seems to be very hard at times. So what I did was, as if they didn't have enough assignments and work, I just decided to increase their engagement by giving them more assignments. And here is the rationale behind it. So my concerns was that, how do I make students attend classes? They don't want to come. I don't want to bring students in class who are so, if they're not interested in coming class, they just distract other people who are interested. So I don't want to force them to come to class. But I do want to engage them in learning the material. So what I did was, I been thinking about it, but there is a STEM academy that I participate, so does Umesh. And I just was talking to one of those faculty, and she said, nobody would come. they would not watch the video unless you make it worthwhile, make them accountable for it. So I came up with this brilliant idea, quote unquote, is that, hey, how about we give them some quizzes based on those PowerPoint lectures? And to ensure that, to give them incentives, because students would never listen to you no matter how many times you try to show them that, you know, you do this for your, it's better for your learning, but unless you give them some kind of incentive with grades, they're usually not interested in doing that. So what I did is I assigned 5% of the course grade by making some assignments. So now they have more assignments because they don't come to class. Now, my focus was not on how to solve the problem. That we do all the time. If they're not getting it, just asking them to solve it, all they would do is either probably Google the answer, go to have Chat GPT answer it for them. I don't really need that. What I want to do is I want a student, when they see a physics problem, think about the problem and pay attention to the underlying physics principle. So, as you know, especially in US, students are not used to seeing word problems. They can do busybody problems. They can do all kind of nice calculus question and all kind of things. But when it comes to reading a word problem and to extract information out of it, that is very difficult for many students. So my method was that I created a Canvas quiz. Canvas is our learning management system. And what I did is it has both multiple choice as well as essay questions. So what I did was I selected a problem from a lecture slide, and then I gave the answer. So I didn't ask them to solve the problem. I gave the answer and I asked them questions with following focus. The focus is that in a multiple choice question, why do you think this is the answer? And I would give them a bunch of choices, and sometimes it will just be choosing one of the reason that is the best reason, or sometimes it will be a multiple choice, but then I would make it an essay question within multiple choice, and I would say, well, so now let's say that you just chose the answer is D, but why do you think D is the answer? Write a sentence or two. And then there are these essay questions where I would ask them to explain. Again, the goal is not to have them solve problem, but the goal is them to get started. What should you think before you solve a problem? Because most of the time, as you have, you're aware of, once they know how to start the problem, they can finish it, because math is not an issue for many of them. The issue is how do they know how to get started from reading the word problem. Now, here is one of the examples. I got 3 examples to show you. So here is a question that I had asked them in one of those video lecture quizzes. I call those video lecture quiz because it's from, I have videos that I already made pre-recorded, but also their PowerPoint slides. So I tell them which slide number, which video lecture number, and then in one of the slides, there's something called property number 2, which talks about conductors in electrostatic equilibrium. And why is that property number 2, why does it work? So then I have, this is one of the multiple choices where I did not want them to just randomly select an answer. I want them to tell me why they selected it. And in this one, I asked them to explain, but the explanation for this one basically is given in the question. I just wanted them to write a little bit more than B is the answer. But in this case, if you place a charge in a conductor, if it's in electrostatic equilibrium, then the charges will go to the outside surface of the conductor because they repel. So B here is the answer. And so let me show you the slides that the students see. And let's see. All right. So these are the slides. So I told them to go from slide number 10 to slide number 15. So this is slide number 10. It's the topic is about electrostatic equilibrium. Charges will go to the surface. One of the property, this is from a textbook that we use. Property 1, they called it, is electric field is 0 inside a conductor. Fine. And property 2, this is the question that I asked. And here's a one little sentence here about why the charges will all go to the surface of the conductor and why it would do that. So then there is also listed property number 3, which says that electric field is perpendicular to the surface when it comes out of the conductor. And then insulators, the charges do not move, they just stay wherever you place it. And then 15 is that the density of charge is higher if you have a sharp corner. So now let me show you what some student response were. Remember, I have 100, this was from spring semester. I have 100 and the last count was 197 students in the class list. So this student's answer was B. I believe B is correct because all charges, extra electrons, will go to the outer surface of a conductor to get as far away from each other as possible. This is because negative charges would repel. So this was a nice answer. So usually the points are 2 points. If it's very simple, sometimes we give 1 point, 2 point, or 3 point. That's it. This one was not very good because the charges placed are attracted by excess electron on the surface. But the choice was correct, but the explanation was not. So when student gives response like that, we have a grading rubric. Like if they make the correct choice, then we give 50% for the choice. But then the other 50% is, did they write a reasonable explanation? This student said D, which is that none of those are right. And this student goes that electric field is 0 everywhere inside a conducting material. This is correct, but it does not answer the question I asked. I only asked a question about property 2, which is that the charges go all to the surface. So it has to be relevant to the question asked, not just some randomly selected answer. But we never give anybody 0. If they wrote something, we give them always some partial credit because I need to know my 0 versus 0. 0 for students who do not participate, and then somebody who participates but is completely clueless, we give them what some of my TAs called it pity points. So at least we know that they're participating. All right, so this is another example. This one is a little bit more involved. So this is the equation for electric potential. There are 2 equations in their equation sheet. A lot of students will just look at, they go with the variable. They would see that there is a potential equation here and another potential equation here. How do you know which equation to use when you're solving a problem? So these are the 2 slides that I mentioned. Video lecture 6, slide number 7, and then lecture 5, slide number 25. So this one is about uniform electric field. That's when they're using this equation. And when your potential is generated by a point charge, then that would be the equation. So I want these things for them to be aware rather than just complete random. I don't want to say that that doesn't happen, but at least most of the students will think about it. So in this case, there were 2 conditions, if you think about it. There are 2 equations. One is for uniform electric field. The other one is for a point charge. So this student said that you would use the first equation when you have a uniform electric field, which is correct. But this student did not mention when would you use the second equation. So we gave credit for the first one, but not for the second one. And this one, again, the first one is correct. You would use the first equation when charge is in a uniform electric field, but then goes on to say you would use the second equation when force is either in the same direction of electric field or for a positive charge or opposite direction for a negative charge. Second one is true no matter what. This is between charge, electric field, and force. So it has nothing to do with electric potential. So we could not give full credit for that part. Now here is a question. We gave, it's short, but if you look at it, it doesn't completely make sense, but at least this student addressed it. It said that you would use V negative delta X for a plate uniform field. I'm assuming that the student over here, we talked about uniform field. Where do you see uniform electric field? It's between the plates of a parallel plate capacitor is an example that I always use. So I think the student was thinking in that way, but we gave full credit for this one because at least the student was mostly correct and was in the thinking in the right way. Short but correct. And here is a nice answer. I like this one. This student goes to say that you would use the first equation when you're determining change in electric potential by analyzing displacement along the line of uniform electric field. So this is a very nice explanation for that one. And you would use the second one when the electric potential of a charge at point P, where Q is the source charge, K is a constant, R is the distance from the source. This was a very nice explanation. But we give full credit for both of these two, that is addressing both questions, a part of the question. Now, this one is another example. This one is lecture 7, slide 16. And here is the question. It is about a capacitor which is connected to a battery and it has charge Q. So all we did is you change the battery, you double the potential difference, and then what is going to happen? So again here, remember I told you that my goal is to have them think about why would you choose this as the correct answer. So I told them the correct answer here is that the capacitance remains the same, but the charge is going to double. So why is this the correct answer? I don't want them to write too much. I just say, just to the point, give me a sentence or two. And I gave them a hint that there are two equations for capacitance. And how do you know which one to use? And both should be consistent. So the answers that we got here. The capacitance is a property of capacitor itself, that is to determine the, okay, so this student talked about the capacitance is property of the plate, the distance, it does not have anything to do with voltage or what circuit you connect it to, which is fine, but this, in this one, the capacitance stays the same is correct, but the student did not address why would the charge double. And then the second one is, this is because when the charge is double, the capacitance must remain the same in order for the voltage to be double as well. But it did not say why the capacitor should stay the same. It needs to address both of those points. And then this one, I thought, oh, sorry. I thought there was a, both of these, second and third one, both of those have the same issue. They don't, the student did not address exactly why the capacitance should stay the same. The last two with green border, these are correct address, a correct answer. They address both why the capacitance should stay the same, and also if using the equation that C is equal to charge divided by voltage, if the voltage is double, then the charge must also double, so capacitance stays the same. And the last one I like, the student went on to show with equations why everything stays the same, and then shows again with equation that if capacitance stays the same, when you're doubling the voltage, then the charge must also double. So these are the things that's all written by students who are reading those lecture slides, and they are also coming to live lectures. So I think, you know, it's always a very good thing to see what, I mean, I find it very interesting what we say, what they take in, and how they show it. It's very, very big difference between all these things. So these are just some good examples that I showed you. Now the question is, how do I do my video lecture quiz setup, the deadline and grading? So these are based on my PowerPoint lecture slides. So what I do is I use the new Canvas quiz, which allows students to earn partial credit for wrong answers. So these are all graded by computer. We don't have to do it by hand. There's classic Canvas quiz. We used to do that by hand. If we said, well, if the student chose this, this, and that, we can give, depending on how wrong they are. There is no time limit. So I don't give any time limit, but there is a deadline. And for multiple choice questions, I only give them one submission. But they can change it as many times as they want until they submit that assignment. So until they submit, they can select whatever, and then they can go back and they can say, oh, maybe that was not right. They can talk to each other. I'm fine with that. But I do not let them have multiple submissions because it's going to be graded at the end. It just seems more reasonable and to just make one submission, but you can change it as many number time as you want. Same with the essay question, the students can change their answer until their whole assignment is submitted. Now, the grading is that the multiple choice questions are graded by computer with partial credit. I assign different kind of choice. How wrong you are depends on that, how much partial credit you can get. The essay questions are graded by hand by TAs. I usually talk to my TAs before we grade. We grade some of them together with a grading rubric. And because, you know, when they're, a lot of the time, the difficulty is that are we reading their answers correctly? And how do we know that did the student addressed what is needed? Now, one thing that I want to say over here about this grading by hand, I grade also AP Physics exams. So a lot of my grading rubric comes from, if you guys are familiar with grading AP Physics exams, looking at the grading rubric, how the points are assigned. So that was a big help for me. So there were, on average, we gave them 2 video lecture quiz per week because we have 2 lectures per week. And they're available for usually 10 days before the deadline. So they have plenty of time to work on it. And then the deadline is usually Friday night at 11:59 p.m. I noticed that anytime I make any kind of exception, they just completely screw up everything else. So I just decided that no matter what it is, the deadline is always Friday night at 11:59 p.m., but we do give them a grace period. The grace period is Saturday, 8 a.m., because there could be all kinds of things that can happen at night. You know, I don't want them to say that, oh, it passed by the time they submitted, it went beyond midnight. So we just let them have, we don't do anything until Saturday, 8 a.m. After that, penalty kicks in. And then 50% penalty if submitted after the grace period. And the cutoff is usually Sunday at 11:59 p.m. So by cutoff, what I mean is that they cannot submit anymore. And if they have started one, Canvas will automatically submit it for them. So I was concerned about adding another set of assignments on top of all the extra things that they're already doing. So but it is important to engage them. It's just that they don't come to class. They have to somehow be able to do well for the course that they signed up. So we try to help them as much as we can. They can collaborate with each other. They can learn from each other. Peer learning is always very good. It is an open book assignment, so they can have fun learning. So many questions, when I talked to them, many students, they told me that they found these video lecture quizzes helpful in their learning because that kind of puts things in perspective a little bit. And these are easy points for them to earn. As long as they stay current, they can very easily earn points. So, you know, if you're just giving them exams and quizzes, many students are not good quiz taker. So these are, I have a lot of assignments like this one where they can build their course grade. So what I call this as an easy course grade builder. We don't give anybody 0 as long as they're answering questions. So I like to make sure that there's a difference between students who are actually doing the work versus students who are not doing anything. For these video lecture quizzes, I do not give any extensions. Once it's done, it's done. Because I showed them the answer afterwards. And I do allow extension for some other assignments, like we have some assignments in WebAssign. I made those extensions very easy. They can get as many extensions as they want, as long as they do it within 5 days and so on, but not for video lecture quiz. So it's very difficult these days to engage students in coursework. This is one of the ways that I find of engaging them in an algebra-based introductory physics course. I think that these types of quizzes can be modified for other classes, including more advanced class. Every class is different. And I just want to thank you for listening. If you have any questions, I'll be happy to answer.
Oh, thank you, Dr. Farida, for outstanding presentation. And it is very practical. One thing I immediately that caught me is not giving zero, even if the wrong answer. That is fantastic idea. So that will encourage students to work on the problems. But my question just to on that is, so don't they have impression that, oh, I mean, probably you might clarify, like getting some points doesn't mean that you will get, I mean, you will be doing exactly right, but don't they get an impression that, oh, I have done something good, right? So I got some kind of points, but otherwise.
Right.
Mm-hmm.
Right. So that's a very good question. And we were thinking and wondering about that. Now, this is my philosophy. A student who's getting, let's say that if they give you a totally irrelevant answer, we have something called irrelevant answer. So if it's a 2-point question, we give them 0.5. So in a 2-point question, if you're earning 0.5, you're not going to pass the class from just answering gibberish. So it's just for, it's my way of bookkeeping, that at least I know when a student comes and talks to me that that I worked hard, then I can say, well, let me see what you did. And then if I see that the student was doing work but got very low grades, then I would say, well, we give students a lot of, study hall hours. We've spread it out throughout the days between my TAs and myself. We do it in the morning, we do it in the afternoon, we do it at night. It all depends on, everybody's availability. So we work it out. So then the question is, well, if you were struggling, why didn't you come to us? But at least I know the student was doing work. But that student is not going to pass the class by just writing gibberish. So it's a pity point. It's not really, it's just for my bookkeeping that are you doing the work, participating or not. But if your just participation is not going to earn you a passing grade, you have to be able to answer questions.
Excellent. Thank you. Thank you so much. Now, this is a Q&A time. We have plenty of time for Q&A. So anyone, if you have question, please unmute and ask to the speaker. If you are uncomfortable to speak, please type the question in the chat box. I can read the question. So thank you so much.
Dr. Mohiuddin, this is Bir Bahara. I have a question. You said your quizzes are in Canvas and the quizzes are auto-graded. But when choosing the multiple choice answers, you said students also should explain how that explanation will be auto-graded.
Okay, so there are 2 types of multiple choice questions. One of them is computer graded. So the one that I showed you, this one, this is a multiple choice where they had to give an explanation. And this one, I did not give them the correct answer choice, but and this one is where I wanted them to give an explanation. Why did you choose it? But there are some other multiple choice questions where I do not ask them to explain. They just choose one.
Okay, I understand. Thank you.
Mm-hmm. Yeah, because a lot of the time what we found is that students would just randomly select something, right? I mean, when we give them exam questions and then they would say that I just, and they go over their exam with me, a lot of them. So I asked them, why did you choose this thing? They said, I don't know, I just chose it randomly. And I know that by randomly, they could get it right, they could get it wrong. So and there are times I do let them get away with just a random choice. But there are other times I would say that, okay, so you chose this answer now. If you want to get full credit, especially in an exam, I would ask them, so here is the multiple choice. If you want to earn full credit, then you have to give me an explanation. And there are some multiple choice, I don't bother with any explanation.
Mhm.
Hello, can you hear me?
Yes.
Yeah. Thank you so much, Farida, for the presentation. It was very good. Nice presentation. I have a question about the participation rate, because I'm doing the same thing in a 300 level course, and this is a flipped course, and I teach 9:30. It's very difficult for them to make them come at 9:30, even though it's not too early. So I do the similar thing, but my participation is not 100%. So I call it a pre-lecture quiz.
Yes.
Before I begin the class, I give them pre-lecture quiz.
Yes.
And even then, the lecture is there online. They're supposed to watch it and come prepared. And the student, I give them some credit, like the way you do, but it's still the participation rate is not 100%. So how is your how is it in your case? How is the participation rate in your case?
Well, we have these web assigned. Remember, I told you that there are some assignments that I do give them extension, easy extension that they can. That I just tell them that you don't even have to involve me. Just go to WebAssign, and once the deadline passes, you just request automatic extension. And those are pre-lecture quizzes. I call them reading quizzes. They're supposed to read a certain amount, and then and I usually make the deadline before the class. My class starts at 5:30 in the evening, but the deadline is at 5:15. So we don't. But then if many of them say that they can do a better job after my lecture, they listen to it. And all of those are fine. As long as they're learning, I'm happy with it. But participation in a class of 197 students, I was getting like 20 students, less than 30 students. After the first week, the attendance went way down. But I give my lecture online and I record it, and I know that many of them do watch it afterwards. They cannot come for whatever reason. And I think that's one thing that happened during pandemic, is that we got very much into the Zoom online. And I just think about, if I do this thing as a live lecture, I'm not recording it. If participation is so low, then they're not getting anything. Right. And they lost completely. So so this, to engage them into coming to class and learning material, what our university has done in our department, we do something called recitations. So for recitations, it's a problem solving session. For that one, we take their attendance. And I always have very good attendance for those. So it's in small sections. There are like 30, maximum is 35. And usually on average, it's about 30 students per section. So this 197 students got divided among all the smaller classes. And I like to go to all of them. Many faculty would just give it to their TA and let the TAs do it. I just happen to be different. My philosophy is that I like to know my students.
Right.
And since teaching this class is the only thing that I'm doing, I'm not doing any research. This is fine. I don't mind going there and working with the students along with my TAs. The TAs are there as well. And so that's where we get most of the participation. However, what I noticed, and even though I told them, no matter how many times you told them, they just it somehow doesn't sink into their brain and taking action about it. Is they would come and they would expect to learn everything during that recitation period.
Okay.
So it is like lifting a heavy load, but we do our best.
Right.
Okay, thank you so much. Dr. Meem Nakarmi has raised hand. Please unmute and ask a question. Dr. Nakarmi, thank you. Is that right? Okay. In the meantime, if any other questions, I saw Dr. Nakarmi raised hand.
Yeah, can you
Yeah, please.
Can you ask somebody else to ask first?
Oh, okay.
Because I need to be
Sure.
I can come back.
Yeah, are there any other questions? Please unmute and ask. Thank you. Let me see. I'm also tracking the chat box. I don't see any questions there.
Now, there's one more thing I would like to share with you. I don't have it here with me, but I'm sure you have the same experience, is that we give students equation sheets, right? And those equation sheets, they just, during an exam, what I see is that they're just looking at that equation sheet like, I don't know, like I call it the frozen deer effect. They're just like a deer stuck in a headlight. They're just staring at the equation sheet, not knowing what to do. And anytime I see that, I always say, okay, I know that this student didn't do enough practice, so I have no idea which equation to use. And then they just randomly select an equation. So what I did this semester was the first time I did this thing. What I did was I asked them that, there are certain questions, certain equations that goes to a given unit. So we have 3 units, electricity, and then we have magnetism, and then we have optics. So so I told them that, so now I started it from the 2nd unit. I said, that this is all the questions will be about magnetism and circuits. So go ahead and draw pictures. So I call it equation to figure concept map. I have them draw pictures and then decide how would you know what equation to use. Let me, we did a poster presentation on that. Let me see if I can find that one and I can show you what the students did. They really, I think of all the things that I did, that one was the most, I think that one had the most positive feedback. So I tried just different things. I've been, at least now, I am a little bit comfortable about what I want the students to do. So let me show you some of the examples that what my students did, and let me share that with you. Hold on. Let's see. I will make the screen a little bit bigger so you can see it, but just a second. Okay, so let me share the PDF. All right. So this was something that I shared with my with that STEM Academy that I was telling you about. So this was something that the students did in their concept map. I had to give them incentive. So these were the equations that were related to magnetism. And these are just some of the examples. When I kept on telling them you should draw pictures, nobody was paying attention. So then what I did is I gave them incentive. I said, I'm going to give you 3 extra points that I'm going to add to your exam 2 score. So that was a midterm exam. And this time, out of 197 students, 119 students submitted it. So that was a big success, because before that, when I asked them for exam one, only one student submitted that, because I didn't include any points. So giving them, I don't like to inflate my course grade, but this one was good because with this one, at least, I'm not inflating it by much. I'm just adding 3 points in a unit exam, which is 14% of the course grade, only adds less than half a point of the course. But if that makes them learn something in the process as they're drawing pictures, they have to think about it. I'm happy with that. So these are a couple of things that students submitted. So this is another thing that I did to improve their engagement. It's very hard. I don't like equation sheet because it puts emphasis in the wrong place. But I noticed that, sometimes you just have to follow along with the traffic. They will not give up their equation sheet. And that's their lifeline. So I said, well, if that's what you're going to do, then use it. Learn to use it. So this is why I did that concept map, that they submitted it, they drew it. So that's something that came up.
I think just to clarify, so you will give these concept map in the exam, or they will
No. I made another Canvas assignment. So
okay.
It's a file upload assignment.
Okay.
So I always force them to submit only PDF file, because if you ask them to they take picture with their whatever camera they do, but if a lot of the time we cannot open their files. So I always force them, anything that is file upload, it is always in PDF format. So they upload their file in an assignment, and then I graded these. It's out of 3 points. I mean, it's mostly to see completion, some correctness, but mostly, did you do that? But they really liked it, and some of them they told me that once they started to do this drawing, that's when they realized that, oh, this is how you're supposed to think about it. So this is another thing that I did.
Very nice. I have one quick question, like what is the TA student ratio or student TA ratio, that what is for like class of 197, so how many TAs or learning assistants do you get?
It all depends on how many TAs Dr. Silva can give me. I had, for this semester, when I had 197 students, I had 5.5 TA. Yes.
Okay, thank you so much. So Dr. Nakarmi, you're ready with your question?
Yes.
Please.
Okay. Thank you very much for this nice talk, because when I teach, I also have the same problem, like students always try to go to the equation first, right? Before trying to understand what this question is about and what they have to think first before looking for the equation. And I think the way you develop this trick, it's very interesting. I will also try to use this next semester.
Yes.
So in your example given here, you gave some multiple choice question leading them to understand the question. So after that, do you give some question to solve similar type of problem?
We don't, the thing is that when I give them those questions, those are based on it's the beginning part of solving a problem.
Mm-hmm.
Because you have to first think about, how do you even know which equation to use? For example, that potential problem that I was showing earlier, so just a second. Will it allow me? No. So let me go back to that, this one. So over here, if you look at this question here, they go to the equation sheet, they see a V, and then they just randomly select whatever. And I don't want them to do that. So this is the very first thing before you can even solve a problem. You need to know how to read the question, because the clue is always given in the question as what equation would you need, because it probably will say in the question that it is the charge is moving in an electric field between the plates of a cap, or in a uniform electric field, or a charge is moving in a field that's generated by another point charge. So they have to kind of know what is happening. And I'm not going to say that it was a very big success, because it's a large class with students with different kind of interests, different level of participation. But the ones who do want to study, but are, I'd say struggling students, I do have a lot of struggling students. By the end of the semester, they do end up getting an A. And that's because of the amount of work that they're willing to put in and the guidance that we give them.
So I'm trying to understand. Do the student complete the problem after this?
They would be, yes, they do
Or
see
at
problems
home,
that would
or
be, yes. I mean, these are the problems that are based on the concept of that week. So yes, there will be problems in WebAssign, there will be problems in quiz, there will be problem in exam. So yes, they do see them. Yes.
Okay. All right. Thank you.
Okay, thank you. So we are almost towards the end of the hour. Do we have any more questions? We have about 3 minutes for the hour. Do we have any other questions? Please unmute and ask the speaker, please. Thank you.
I need some clarification on this concept map. So is this the concept map you allow them to submit every midterm or exam, or?
It's right. Well, this is the very first time I'm doing it. This semester. We just finished spring semester. It's the first time I did this, and that was the outcome. So here is what I saw. At first, I just wanted them to, be engaged, do something, rather than just stare at the equation sheet. So what I did at first in the second, I started it from their second midterm. We give them 3 midterms. So in second midterm, I made the deadline on the day of the exam at 11:59 p.m. So what I noticed is that some of them submitted afterwards, but they just submitted because they wanted to get extra credit point. They didn't care what they were submitting. So I didn't like that. So then what I did was for third midterm, I made the deadline before the exam. So our exam was at 6:30 p.m. I made the deadline 6:15 p.m. And I kept on reminding them that you will not be able to submit afterwards. And I had to keep on reminding them that don't just make it. As long as you're spending the time to make it, use it. Don't just do it for getting extra credit. And then I became more strict about who is going to get all 3 points. It has to be meaningful enough to earn all 3 points.
Okay. Yeah, please.
Is this the concept map is just based on the question you ask in the midterm, or everything covered before?
No, it is all based on the equation sheet.
Oh, got it.
Let me show you quickly. I know we're running out of time, but let me just quickly show that one more time. Here is the concept map, and let me show you our equation sheet. So this is based on this equation sheet. And so I told them that you know what question, what of these equations will be in, say, if it's a midterm, second midterm, then it will be current resistance and magnetic force and magnetic field. Okay. So they had to draw the concept map based on that. And for the third midterm exam, it was the last bit, electromagnetic waves and geometric optics. And they had to draw based on that. So it's not based on my question. They don't know what question I'm asking. They just have to know how to use the equation sheet.
Okay, thank you so much. That makes sense now.
So they can bring the concept math
No.
during the exam.
No,
I see.
no, that would be a disaster.
I really like this idea of like this is actually they at least they know what's going on in on that equation. Like as Dr. Nakarmi pointed out, like when we give the exam, students start looking for equation rather than understanding the question first. Like so, this is a great idea. Thank you for sharing. Any last minute question? So yeah, we are actually at the end of the hour. So thank you so much, Dr. Farida, for sharing your experience. This is really useful to our community, to every educators. So thank you so much. Thank you. So let's thank Dr. Farida, and I will now stop the recording. If there are informal discussion, we'll do that. Okay, thank you.
Yeah, thank you so much for inviting me. I mean, I really enjoyed talking to you. I always